This is the video introduction to lesson number 20, Measuring Ohms with a Digital Multimeter, in the Mr. Circuit Basic Electronics Lab number 2. First, let me say that the digital multimeter is probably the most used piece of test equipment in electronics. It is quite versatile and has many functions. In this lesson, we will use a 7-function digital multimeter to measure ohms. If this is your first introduction to a digital multimeter, let me point out 3 things. First, a multimeter is a very delicate piece of electronics test equipment and needs to be treated with care. Second, a multimeter has to be connected correctly to the circuit to get good results. And third, you need to know how to interpret the readings on the display of the meter. I am first going to talk about how to measure resistance with a digital multimeter. Resistance is measured in ohms. On this meter, the selector knob has 5 ohms positions or ranges to measure resistance. Let's suppose we want to measure the ohms of a resistor. With the meter turned off, we move the selector knob to the lowest range, which is the 200 ohm position on this meter. Then we turn the meter on and touch the probes to the ends of the resistor that we want to measure and observe the display on the meter. In our example here, we are measuring a 100 ohm resistor. Our display shows the number 98.7. What does that mean? Well, since we are on the 200 ohm scale, it means that this resistor measures 98.7 ohms. Be aware that the 200 ohm scale on this meter will read up to 199.9 ohms. Let's see what the numbers would be on the display if we were to move the selector knob to the other positions. Let's move the selector knob to the 2000 ohm range. What do we see on the display? In our example, we see the numbers 0, 9, 8. How do we interpret that? It means 98 ohms. At this point, I need to explain that most digital multimeters have a limitation on how many digits can appear on the display. Our meter will only show up to 4 digits, and the first digit of 4 digits can only be the number 1. The largest reading that this meter can display is 1999. The lowest number it can display is 0.00. In the 2000 ohm selector position, this meter can only show a maximum of 1999 ohms. So the display could show any number from 0.00 to 1999. Since the display shows 098, you can interpret that as meaning 98 ohms. It is kind of confusing, so that's why I point this out. Let me explain some more. This meter cannot show the number 2000. Why? Because remember, the biggest number this meter can display is 1999. This is because the first digit in the display can only be a 1. This display is referred to as a 3.5-digit display. The last 3 digits can be any digit from 0 to 9, but if there are 4 digits on the display, the first digit can only be a 1. That's it. Let's move the selector to the 20K position or the 20,000 ohms range. Because there is a K after the 20, it means that what we see on the display needs to be multiplied by 1,000. That's what the K stands for. You will notice that our display shows 0.10, and that means 0.10K, which in turn means 0.10 times 1,000, which is 100 ohms. Here are some more examples. Remember that on any resistor range that has a K included with the number, you need to multiply the number on the display by 1,000. Here is a table with ohms being measured with K ranges versus what the display will show. For our exercise here, we will assume that the nominal value is equal to the measured value. That is to say, if we're measuring a 100 ohm resistor, we'll assume that it measures exactly 100 ohms. For example, look at these numbers. If we measure a 100 ohm resistor on a K range, these are the readouts you would get. For a 100 ohm resistor, you would see 0.10 on the display. Look at these numbers and see if you agree. Will 500 ohms show up as 0.50 on the display? Yes. How do we explain that? Well, 500 ohms is equal to 0.50 times 1,000. That's how it works. Study these results. Do you see how that works now? Let's move the selector to the 200K range. We're still measuring a 100 ohm resistor. What are the digits on the display? The display shows 0.1. What does that mean? It means 0.1 times 1,000, or 100 ohms. How interesting! Now let's move the selector to the 2000K position. Note that the 2000K range has a K, but this range can read up to 199.9K ohms, or 1,999,000 ohms. The last three zeros come from the fact that this range has a K. What digits do we see on the display when measuring 100 ohms? We see 0, 0, 0 with no decimal points. What does this mean? This means that the value in ohms is too small to be read out on this meter on the 2000K scale. I hope this gives you a better understanding of how to measure ohms on a digital multimeter and how to interpret the digits on the display of the meter. So far, I have covered the first 4 pages of Lesson 20 in your lab manual. The next 4 pages are about resistor tolerance. The resistors in this lab are all plus or minus 5% tolerance. What does plus or minus 5% mean? It means that the value of the resistor in ohms can vary to as low as 5% less than a nominal value up to 5% more than the nominal value. How does that work? Let's take a resistor with a nominal value of 100 ohms. This resistor would have color bands: brown, black, brown, and gold. If we measure its resistance with a meter, it could measure as low as 100 ohms less 5 ohms, or as high as 100 ohms plus 5 ohms, or anywhere in between. Thus, the resistor could measure as low as 95 ohms, or as high as 105 ohms, and still be a good resistor because the resistor is within the plus or minus 5% tolerance. That is it for this video introduction to using the digital multimeter to measure resistance. You're now ready to finish this lesson by filling in the blanks on all the pages of Lesson 20. If you need to review this introduction again, go ahead and watch this video presentation as many times as you need to. Then, by filling in all the answers in your lab manual for Lesson 20, you are ready to go on to Lesson 21. Also, I remind you, you're now well on your way to earning the certificate for the Mr. Circuit Basic Electronics Lab number 2.